Hello everyone, welcome to this presentation. I'll be describing here the application of the AutoScholar Advisor for automating some of the processes in advising staff and students. So this project uses modern methods from statistics and artificial intelligence to generate this advice to these three categories of users. So staff involved in curriculum design, staff that are involved in the teaching of courses, and of course students. These are expected to be the three main types of users. This project standardizes the data coming to the AutoScholar through an application programming interface, and that's how we are able to use the system across multiple institutions. So the AutoScholar in particular looks to understand the coherence among the courses in a curriculum. So do the concepts scaffold well, and does it all build up to a good capstone event or course? It also helps us to consider revisions to the curriculum in a data-driven way. So does it make sense to add or remove particular courses or content? It can help us understand the performance of our courses, help us compare a course with its peers and across the years and understand the cross correlations among courses. Are there unexpected correlations or lack of correlation, as we'll see later? It also helps us predict student performance and identify those students that may need additional support. It can help us automate the tedious parts of advising. So the frequent queries that should really be automated, it goes ahead and does that. And there's this principle of gamification that's proven quite effective in motivating humans in general. So incentivizing and motivating people to undertake actions that we would like them to. Gamification is a powerful technique that facilitates that. So just to give a basic flavor of the types of information, this is a typical course profile according to the AutoScholar. So here it's reading for a particular course. It's looking at the pass rate and the mean across the years. And then it's also benchmarking that course's performance against the peer courses. So the system can look up for a given course, what are the other courses that students who take that course also doing. So it looks at peer courses, how well does it correlate, and does it make sense for this course to correlate or not correlate with other courses? How does the mean and pass rate compare across all these courses? And then you can see here, and these are just screen grabs from different parts of the AutoScholar. It helps identify these at-risk students. For particular students, it's showing where those students are doing particularly poorly or even particularly well. So this just gives us a basic sense for the sorts of course information we can get out of it. Looking then at some of the more advanced functionality, there's a progression mapping aspect. And in progression mapping, we try to understand the various routes by which students are passing through our curricula. So on this graph, if we plot here the number of students and if we plot the percentage of program credits passed, then if we consider a program that has 100 students entering in the first year, after one semester, so that's what each edge here represents, one semester. So after one semester, that original 100 students may have split up into 70 students who pass everything and 30 students who pass some smaller set of courses. And so we can think of each point as being a combination of courses. So behind each node here, we can imagine some set of courses that have been passed. And so one semester later, that star group that's passed everything, there may be a certain number that go on to also pass everything in the next semester, and some other group that hasn't passed everything. And so at the end of each semester, we can identify how each subgroup has fared, and hence we can construct this frequency profile, and hence understand the various routes by which students are progressing through the academic program. And so this is valuable information to understand the main fail-out points from the academic programs. It helps us understand which courses are causing students to stumble the most. And when we understand this, we are then perhaps able to timetable differently. So perhaps if we timetable differently, we can support things like students carrying a course into the next semester so they stay on minimum time more easily. Or we can look at, does this course need additional support, perhaps additional resources and things like that. So a map like this has various applications, and one being, as mentioned, we can identify the courses that are really causing students to limit their overall progression. We can actually use this progression map to also deduce a curriculum structure. So we have in mind a particular curriculum that we assume students are going to follow, but when we look at the data, we may find that students are actually opting to take courses in a particular order that we might not have planned for, and so on. So a progression map helps with that. And we can use that then to deduce the curriculum in the minds of the students. So once we have that curriculum object, once we can get it out of the data, we can then start dispensing real advice to students. So this slide is not really something I'd advise that we show to students, but for instance here, it's estimating for a particular student how much extra time that student has taken. So it's looked at all the courses where the student has taken extra time and said quite judgmental things like your study is subsidized by the government, and by taking this extra time to complete, you've cost the state and university extra, and that's also a loss of earnings to you. So perhaps this one is more important. But generally speaking, you can determine these sorts of things once you have the curriculum. Some other experiences we've had with the AutoScholar from the area of accreditation tracking. So in engineering, for instance, we have the Engineering Council of South Africa that accredits our courses, and we can automate the accreditation process because the system links directly to the records database. It's able to determine whether or not students have attained the exit level outcomes, as they're called, and when we apply this, when we give students access to this kind of information, we find they are extremely sensitive to the things it's saying about them. And we find many queries coming from students that show a high level of interest in what these sorts of dashboards are saying. So that's why I say this is like accidental gamification. So if you think of systems out there like Facebook and other social media, gamification is when you have a user who's trying to increase the number of friends, for instance. So gamification doesn't have to mean that you actually create a game, but the game-like behavior where you might be trying to increase your score in some way. So dashboards like these can promote that kind of behavior, and we can tap into the gamification behavior to drive or to use it for academic purposes. And here's a screenshot from one of my other research projects. Here we are involved in a fleet of vehicles, and we have the data from this fleet, and we can create leaderboards where we can show the drivers how well they are scoring, and we can rank them. We can also create a heads-up display, so while they are driving, we can get a constant update about how they are performing in the various areas, and then they accumulate badges over the months. So for fulfilling particular criteria, they collect these virtual awards. So this kind of approach can be applied for educational purposes also, and we can have students starting to compete more effectively and trying to accomplish particular things that we would like them to do. So gamification approach is something of particular interest. There are other basic things it can do, such as looking at the registration advising. So have you satisfied all the criteria for undertaking a course? So it says here, yes, you can register for these things, and then importantly, it also says you can't register for these things because of these reasons. So it can take a student's profile, compare with the rules, and then come back and dispense the, clear advice to the student. So that's an example of a feature that can really save a lot of time in our academic advising. In terms of curriculum design, one of the basic things we can do is consider statistical processing and trying to determine whether the courses are really scaffolding as we'd like them to. So here's some data for an academic program where we are showing the first year courses in the row space of this matrix, and then across here we've got the second year. So first year courses down here, second year courses across there. And we are cross-correlating the students, so students who have taken, let's say, this pair of courses, we cross-correlate their results, and in this case we find there's very low correlation between these courses. This is a chemical engineering course, and these are two chemistry courses. So we surprisingly find a low cross-correlation between the first and second year chemistry. In fact, a higher correlation between first year chemistry and our chemical engineering course here. And if we look across this, we find here this course, which is supposed to be Introduction to Chemical Engineering, actually has a very weak correlation with our chemical engineering courses. So this flags for us that perhaps this course is not living up to its name of introducing chemical engineering, whereas this course, which is Physics 2, actually compares quite well. It actually correlates quite strongly with our second year courses. And in fact, this is a course that's routinely thought of in terms of reducing content. Why do chemical engineers need to know so much physics? So this is an example of where data sometimes goes against your intuition, and it tells you actually this might be serving an important foundational role. So this description is just a brief sort of note that you can use this kind of basic processing to understand your curriculum better, and then you can take some algorithms from artificial intelligence, and here's where we took the data for 4 courses and tried to predict a fifth course, Reactors 3. We throw the data in, and it tells us if you want to predict Reactors 3, you should first check Reactors 2. These courses don't seem to influence Reactors 3 much. If you check Reactors 2, if you have very low marks, you likely fail 3. If you have very high marks, you likely pass. If you have marks in the middle range, it's not enough to check that. You should also check this maths course, and so it constructs for us a model that we can use to predict whether a student will pass or fail. And what's even more important is it's giving us a kind of precedence of concepts. So it's helping us understand which courses most influence that Reactors 3 course. In other words, we could use this to understand which courses really should be prerequisites or not. A lot of this is driven by research interests, and I'm currently in the process of exposing a lot of these tools for use by other staff. So we are looking at generalizing these methods and exposing them for other staff to use in finding other relationships. So there's quite a lot of data in the database, and there are more correlations that are just waiting to be found, and this is all publishable research. So I hope we can find more collaborators who can assist us in understanding our students better. So in conclusion, we have automated advising to students and staff, and progression mapping is one of the key concepts there for analyzing the curriculum. We believe that gamification may have an important role to play in motivating our students better in the directions that we'd like. The methods in statistics give us valuable insight into our curriculum, and we are at the beginnings of really predicting what's going to happen in courses and really identifying which students may need additional support. And we have this collaborative framework that we hope will help us create a network of researchers that can help us really understand our students and our curricula better. Thank you kindly for your attention.